The 2026 enterprise landscape demands a strategic transition from massive data ingestion to the precision of frontier model capabilities through neural architecture optimization that redefines how organizations extract truly actionable intelligence. Today, we explore the science of inferencing to understand how modern systems derive logic from unstructured data while maintaining high-fidelity standards across global digital ecosystems and professional technical frameworks. As we navigate the complexities of 2026 SOTA benchmarks, it becomes clear that mastering model orchestration is the definitive competitive advantage for leaders seeking to scale their specialized digital operations effectively. This roadmap provides a comprehensive analysis of the computational logic required to transform raw information into structured decision matrices while ensuring robust compliance with the latest international technological governance standards. We will demystify the internal processes that allow frontier models to generalize knowledge across diverse data sets, providing your organization with the necessary tools to achieve unprecedented levels of operational excellence. Prepare to immerse yourself in a data-driven journey that bridges the gap between theoretical machine learning research and the practical realities of deploying high-performance, enterprise-grade artificial intelligence solutions. In the United States, the NIST AI Risk Management Framework sets the global gold standard for securing these intelligent systems and aligning them with the most rigorous ethical protocols available. Canada continues to lead through the Vector Institute, where deep learning research focuses on the ethical integration of these technologies into the broader economy to enhance human potential and productivity. Across the Atlantic, the European AI Alliance provides official updates on the AI Act, ensuring that all neural architectures meet the stringent standards for trustworthy and transparent artificial intelligence development. Mistral AI in France specifically pioneers efficient sovereign models that offer high performance while maintaining the digital autonomy required for sensitive industrial applications within the complex European regulatory environment. In the Asia-Pacific region, SoftBank Group catalyzes the information revolution by intersecting robotics with advanced reasoning agents to create a seamless synergy between physical automation and digital cognitive processing power. Baidu Research leads the way in China with significant developments in multimodal frameworks and deep learning structures that allow for more sophisticated interpretation of diverse and high-volume, unstructured data streams. Latin American advancement is accelerated by CENIA in Chile, where tracking sovereign model development ensures that regional technological growth remains competitive within the rapidly evolving global digital economy and landscape. The Alan Turing Institute in the United Kingdom serves as a critical national hub for data science, focusing on the intersection of defense security and public policy for resilient infrastructure. Inferencing represents the critical computational phase where a trained model applies its internal learned logic to deduce accurate answers from novel and previously unseen data points in real-time enterprise environments. This process differs significantly from the training phase because it requires the neural architecture to perform high-speed mathematical transformations on input vectors to generate coherent and contextually relevant output signals. By demystifying this logic application, we can better understand how frontier model capabilities enable systems to recognize patterns in unstructured formats, such as natural language text or complex visual imagery. The underlying structure relies on sophisticated layers of neurons that weigh information based on historical training, but must ultimately remain flexible enough to handle the unpredictability of live data inputs. Research from the Allen Institute for AI highlights how open-source architectures like Ulmo are advancing our understanding of how these logic gates function to provide common good and scientific discovery. Model orchestration ensures that different components of the system work in harmony to minimize the distance between raw data ingestion and the final delivery of an accurate and logical conclusion. Stanford Human-Centered AI emphasizes that the transparency of these architectures is essential for maintaining digital trust and ensuring that the reasoning process remains explainable to high-level executive decision-makers. Understanding this fundamental architecture is the first step toward optimizing your organization for a future where every piece of unstructured data can be converted into a valuable strategic organizational asset. A significant shift is occurring in 2026 as global enterprises move their primary focus from the massive upfront costs of model training toward the highly optimized economics of edge inferencing. This transition is driven by the need for more sustainable digital transformation strategies that prioritize immediate operational efficiency over long-term and often unpredictable research and development investments for large-scale models. The University of Helsinki, through its Elements of AI program advocates for broad-based literacy, to help organizations understand the economic implications of democratizing these advanced logic-driven computational capabilities. NVIDIA. Deep Learning Institute provides specialized technical training to help engineers optimize GPU utilization for inference microservices, which significantly reduces the total cost of ownership for modern AI deployments. By focusing on the economics of the edge, organizations can deploy intelligence closer to the data source, reducing the need for expensive and high-latency back-and-forth communication with centralized cloud servers. Microsoft Source reports highlight real-world case studies where industrial-scale generative AI implementations have successfully achieved a higher return on investment by prioritizing efficient inference over continuous model retraining cycles. The World Economic Forum tracks these macro-level shifts in tech governance, noting that digital economies are increasingly defined by the ability to execute logic at the point of greatest impact. Economic resilience in 2026 is therefore tied to how well an enterprise can manage its inference budget while maintaining the high performance required for competitive advantage in a global market. One of the most severe risks in modern deployment is the computational latency that occurs when complex models are forced through hardware bottlenecks without the benefit of proper structural optimization. These bottlenecks can cause significant delays in real-time processing, which undermines the effectiveness of AI-driven tools in environments where split-second decision-making is an absolute requirement for successful operational outcomes. The UK National Cybersecurity Centre provides essential guidance on securing machine learning algorithms to prevent performance degradation and ensure the resilience of sovereign defense strategies against emerging digital threats. ENISA, tracking the 2026 threat landscape, identifies that zero-trust certification standards are becoming vital for protecting inference pipelines from unauthorized access and potential manipulation of the internal model logic. CISA bulletins emphasize the importance of securing critical national infrastructure against disruptions that could exploit these hardware vulnerabilities and lead to systemic failures within the broader technological supply chain. MITRE ATT and CK frameworks offer a globally recognized knowledge base for identifying adversary techniques that might target the inference phase to compromise the integrity of the data output. To mitigate these risks, organizations must implement resilient IT infrastructures that include specialized hardware accelerators and optimized software layers designed specifically for high throughput and low latency inference performance. By addressing these hardware and software constraints proactively, leaders can ensure that their AI systems remain robust, reliable, and capable of delivering consistent value even under heavy computational load conditions. Maximizing inference efficiency is the primary lever for significantly lowering operational cloud costs, while simultaneously accelerating the speed at which executives can make data-driven decisions for their global organizations. This ROI framework requires a deep understanding of how model orchestration can streamline workflows and eliminate redundant computational steps that add unnecessary expense without providing additional value to the end user. McKinsey Digital Insights suggest that C-suite roadmaps for scaling digital returns must include a focus on cloud migrations that are specifically optimized for the unique demands of high-volume logic processing. IBM Skills Build emphasizes that closing the tech skills gap in areas like prompt engineering and enterprise AI ethics is essential for maximizing the practical utility of these advanced inferencing systems. Deloitte Insights highlights the shift toward cloud-native architectures, which allow for more flexible and scalable deployment of inference models across different industries and varied organizational structures for maximum impact. The IMD World Competitiveness Center provides benchmarks on how nations and enterprises adopt these technologies to remain ahead in the global race for digital maturity and long-term economic sustainability. By aligning technical optimization with business objectives, executives can ensure that every dollar spent on AI infrastructure contributes directly to a more agile and responsive organizational structure for 2026. The ultimate goal of this framework is to create a self-sustaining cycle of innovation, where efficient logic derivation fuels faster decisions, which in turn leads to greater profitability and growth opportunities. We have explored the intricate layers of neural architecture, the shifting economics of the 2026 benchmark, and the critical importance of mitigating hardware vulnerabilities to ensure seamless and resilient operations. By integrating these 4 key takeaways into your digital transformation strategy, you can bridge the gap between complex, unstructured data and the clear, logical insights needed to lead in your industry. The synthesis of global research from NIST to SoftBank confirms that the science of inferencing is no longer a peripheral technical concern, but a core pillar of modern enterprise-grade technology strategy. As you look toward the future of your organization, consider how optimized model orchestration and efficient logic application can redefine your competitive position within the rapidly evolving global innovation era of 2026. Our exploration today serves as a foundation for building a robust and high-performance digital ecosystem that prioritizes data-driven results over speculative investments in unproven or inefficient large-scale artificial intelligence models. Remember that the transition from training-centric to inference-centric operations is a journey that requires continuous monitoring of SOTA benchmarks and a commitment to maintaining the highest standards of digital trust. By staying informed and agile, you can navigate the complexities of the 2026 landscape with confidence and ensure that your technology investments deliver maximum value for all your stakeholders and partners. The science of inferencing is the key to unlocking the hidden potential within your data, and we are here to provide the strategic guidance necessary to master this critical technological domain effectively. We encourage you to review the detailed research from the 2026 Global Research Portfolio to deepen your understanding of the specific frameworks and protocols discussed in this comprehensive strategic analysis session. Lead your team with the authority of data-driven insights and the visionary perspective required to transform these complex computational processes into a sustainable and profitable long-term business strategy for the future. As we conclude this session, we remind you that the application of these strategic frameworks is the most effective way to turn knowledge into your organization's greatest and most enduring asset. By prioritizing efficiency, security, and ROI, you are positioning your enterprise at the very forefront of the global technological revolution, ensuring a prosperous and resilient future for years to come. Stay tuned for more deep dive analyses into the vanguard of artificial intelligence, digital transformation, and cybersecurity, as we continue to track the most impactful trends of the year 2026 and beyond. Turn knowledge into your greatest asset by applying these strategic frameworks today and lead the global innovation era. We walk the talk on digital trust. This content is 100% certified, channel powered by generative AI architecture.